In February 1945, a German engineer opened an American artillery shell and realized the war was already lost. Not because of soldiers, and not because of generals, but because inside that shell was proof that Germany was fighting an enemy it could never outproduce, no matter how brave its men were. Eastern France. Snow drifted through the shattered windows of an abandoned textile factory outside the city of Metz. The looms were gone, stripped months earlier for scrap, leaving only iron frames and frozen concrete floors. In the center of the building, beneath a single hanging lamp, stood a long steel work table. Upon it lay 2 American artillery shells, 105 mm this time, scarred by dirt and ice, their olive paint chipped by impact but otherwise intact. They should not have been intact. Dr. Karl Weiss, senior physicist attached to the Wehrmacht's Armaments Research Directorate, removed his gloves and rubbed his hands together for warmth. The cold in the factory was brutal, but he barely noticed. His attention was fixed entirely on the shells. They had been recovered after the fighting near the Moselle River, unexploded, found embedded in frozen ground above German trenches. And yet the reports that followed them were unsettling. Infantry officers described American shells that burst perfectly above ground, showering steel fragments downward with horrifying efficiency. Foxholes offered no protection. Trenches became death traps. Men were killed without ever seeing the explosion itself, only the sudden hammering rain of metal from the sky. Airburst artillery was nothing new, but this was different. Timing fuses depended on calculations, range, barrel wear, weather, propellant temperature. Even the best artillery units failed as often as they succeeded. Wind alone could ruin everything. Yet the Americans were achieving near-perfect bursts. Not sometimes, not often, almost every round. Weiss had been ordered to find out why. He picked up the first shell carefully and secured it in a padded vise. Even a dud could kill him if mishandled. With slow precision, he began unscrewing the nose assembly, documenting each step with a Leica camera. Minutes passed. Then more. When the fuse housing finally separated, Weiss froze. Inside was no clockwork, no mechanical delay, no conventional timing mechanism at all. Instead, he saw something utterly alien. A dense cluster of miniature components, coils, tubes, capacitors, packed with astonishing precision. The craftsmanship alone was shocking. Everything was sealed, reinforced, and shock-mounted as if designed to survive punishment far beyond normal engineering limits. Weiss leaned closer, disbelief creeping across his face. It looked like a radio. That was impossible. Radios were fragile. Vacuum tubes shattered if dropped. Even field radios required careful transport. The acceleration of artillery fire, tens of thousands of Gs, should have pulverized such components instantly. Yet here it was, intact, functional. Weiss straightened and turned sharply. "Lieutenant Adler," he called. From the shadows stepped Otto Adler, a young signals engineer seconded from Siemens, his coat still dusted with snow. "Come here," Weiss said quietly. "Tell me what you see." Adler bent over the table. His breath fogged the air as his eyes traced the circuitry. His expression changed from curiosity to confusion, then to something approaching fear. "This is a transmitter," Adler said slowly, "and a receiver. Short range, but extremely fast response." He swallowed. "And this looks like a proximity circuit. It's emitting radio waves and measuring their reflection." Weiss felt a chill that had nothing to do with the cold. "Meaning?" Adler hesitated, then spoke carefully. "It means the shell isn't timed," he said. "It's sensing." The grooves carved into the shell's casing left no room for doubt. Dr. Karl Weiss ran his finger along the rifling marks, dark with powder residue. The shell had been fired, accelerated down a gun barrel at extreme velocity, subjected to forces that normally destroyed even the most rugged machinery. And yet, the device inside had survived. Not only survived, it had functioned exactly as intended. For hours, Weiss and his small team worked in silence, cataloging every element of the mechanism. Each component was removed, measured, photographed, and logged. The deeper they went, the more disturbing the picture became. At the heart of the assembly was a vacuum tube, astonishingly small, far smaller than anything currently produced in German factories. Its glass envelope was thickened, reinforced, its internal supports engineered to resist violent shock. Nearby sat a compact power system. Not a conventional battery, but something far more clever. Lieutenant Adler identified it first. "A chemical reserve battery," he said quietly. "Inert until launch." Encased inside was a tiny glass ampule filled with liquid electrolyte. The instant the shell was fired, the force shattered the vial. The fluid flooded the battery cell, activating it only seconds before impact. No long-term degradation, no storage issues, no wasted power. A perfect solution. Weiss closed his eyes briefly. German engineers had discussed such designs in theory for years. But theory was cheap. Execution was everything. An antenna folded tightly along the fuse wall sprang outward once the shell left the barrel. It connected directly to a detection circuit. Fast, responsive, brutally efficient. By the time the team finished mapping the circuitry, there was no longer any doubt about the device's purpose. "This isn't a timed fuse," Weiss said at last. "It's a sensor." The shell emitted radio waves continuously. As it descended, reflections from the ground, or any large object, returned to the receiver. When the signal strength crossed a specific threshold, the detonator fired. Perfect height. Perfect burst. Every time. The shell didn't rely on gunners. It didn't rely on calculations. It made the decision itself. Weiss sat heavily at his desk later that night, staring at pages of analysis spread before him. Individually, each component was impressive. Together, they were devastating. The vacuum tubes alone were a nightmare. German electronics production had never fully recovered from years of material shortages, bombed factories, and declining quality control. Tubes were fragile, inconsistent, oversized. The American ones were none of those things. Then there was the metallurgy. Aluminum alloys of a purity Germany could no longer source. Copper wiring without substitution. Insulation materials that showed no degradation. Nothing about this device suggested compromise. Weiss summoned his senior staff the following morning. Around the table sat men with decades of experience, artillery designers, metallurgists, electronics specialists. Many had been leaders in their fields before the war. Now they studied the diagrams in grim silence. "Gentlemen," Weiss began, "what you see here is a complete miniature radio system designed to survive artillery launch." He let that sink in. "The Americans have solved problems we have debated for years. The question is not how this works. The question is whether we can build it." No one answered immediately. Finally, Dr. Ernst Keller, an electronics expert, shook his head. "We cannot," he said flatly. "Not at this scale. Not with our current production." Others nodded. The tubes are too small, one added, too durable. We can't make them consistently. The materials alone are beyond us, another said. These alloys require uninterrupted supply chains. The intelligence file did not read like a battlefield report. It read like an autopsy. Dr. Carl Weiss sat motionless as page after page confirmed what he had already begun to suspect. The American Proximity Fuse Program, identified only as VT in intercepted documents, was not a side project, nor an experimental curiosity. It was a national undertaking. Funding levels alone were staggering. According to estimates compiled from British and neutral sources, the program ranked among the most heavily resourced scientific efforts of the war, on par with the most secret weapons research underway anywhere in the world. The work had been centralized at the Applied Physics Laboratory in Maryland, a civilian institution converted almost overnight into a military research hub. Hundreds of physicists, engineers, metallurgists, and production specialists had been assigned to a single task, making electronics survive the impossible, and they had succeeded. What made Weiss feel faint, however, was not the innovation. It was the output. By the final months of 1944, American industry was producing tens of thousands of proximity fuses every single day. Not per month, not per quarter, per day. Weiss read the line twice, then a third time, as if repetition might soften the blow. This was more advanced electronic equipment than the entire German electronics sector could assemble in weeks, perhaps longer. And each fuse was not a crude device. It contained precision glasswork, tuned circuits, calibrated components, and fault tolerances that bordered on obsessive. They were building miniature radar systems in quantities normally associated with nails or rifle cartridges. Production had been distributed across multiple civilian firms, telephone manufacturers, radio companies, factories that, before the war, had made household appliances and consumer receivers. The Americans had not created a new industry. They had redirected an existing one. Weiss pulled German production summaries from his briefcase and placed them beside the American figures. The comparison was brutal. In all of 1944, Germany had managed to complete roughly 40,000 aircraft, fighters, bombers, trainers, everything combined. The United States was manufacturing more proximity fuses than that every day, and artillery fuses were only a fraction of American output. The intelligence reports continued. The VT fuses had first been deployed in naval and anti-aircraft roles more than a year earlier. Against aircraft, they had proven devastating, multiplying kill rates without increasing ammunition expenditure. Against flying bombs, they had turned near misses into guaranteed destruction. Most alarming of all was a note on doctrine. The devices had been deliberately withheld from ground combat, not because they were unready, but because American command feared capture. Only when the Ardennes offensive threatened to destabilize the front had they authorized their use on land, which meant one thing: they no longer cared if Germany discovered the secret. Weiss leaned back slowly. That confidence could only come from one source. Another folder contained a translated British assessment of American industrial performance. The language was dry, almost polite, but the conclusions were staggering. The United States, it stated, was producing more war material than every other belligerent nation combined. Not just Germany. Germany, Britain, the Soviet Union, Japan, and Italy, all together. Aircraft production figures were included. In 1944 alone, American factories delivered over 90,000 aircraft, and not light machines, heavy bombers, transport planes, long-range fighters. Each one consumed more aluminum, labor, and precision work than several German aircraft combined. A single four-engine bomber required material equivalent to multiple fighters. Dr. Karl Weiss read the final paragraph of his report one last time before signing it. The conclusion was unambiguous. If an enemy could simultaneously outproduce Germany in aircraft, armor, naval vessels, artillery, and precision electronics, by margins measured not in percentages but in multiples, then the outcome of the conflict was no longer a matter of courage or ingenuity. It was arithmetic. No battlefield brilliance could compensate for such disparity. His recommendation was brief, almost clinical. Further resistance will result only in additional casualties, without altering the strategic outcome. An immediate political settlement should be pursued while any negotiating position remains. When Weiss handed the document to his superior, General Major Reinhardt, the older man read it in silence, his jaw tightening with each page. "Karl," he said finally, "you understand how this will be received." "Yes. This borders on defeatism." "It borders on reality," Weiss replied. Reinhardt studied him for a long moment, then nodded slowly. "I won't ask you to change it," he said. "The analysis is sound. I'll forward it." He hesitated. "But don't expect gratitude. Truth is rarely welcomed here." The report disappeared into the machinery of the Oberkommando der Wehrmacht. No acknowledgement followed, no questions, no requests for clarification. Weeks later, through unofficial conversations and whispered remarks in corridors, Weiss learned what had become of it. Dismissed. One senior officer reportedly scoffed that the conclusions reflected academic despair. Another claimed the engineer had been psychologically weakened by enemy technological tricks. "It is a temporary advantage," one comment read, "not proof of superiority." Weiss felt no anger, only exhaustion. He had seen this pattern repeatedly. Any intelligence that challenged ideological certainty was rejected. The system required belief, not verification. Germany's leadership had bound itself to the assumption of inherent supremacy. To accept evidence of inferiority, especially from America, would unravel the entire narrative on which authority rested. Yet Weiss could not forget what he had held in his hands. He had measured it, weighed it, counted it. The truth was not philosophical, it was physical. Germany was not losing because its soldiers lacked discipline, nor because its commanders lacked intelligence. It was losing because it had entered a war of production against a nation that treated manufacturing as a science in itself. And science, unlike ideology, did not bend. Although the report failed to move high command, it circulated quietly among officers closer to the front. One of them sought Weiss out. Colonel Martin Vogt, commander of an artillery regiment recently withdrawn from the West, arrived unannounced one evening. His uniform was worn, his face lined beyond his years. "I read your analysis," Vogt said without preamble. "I need to know if it's accurate." "It is," Weiss answered. Vogt exhaled slowly. "At the Ardennes," he said, "we lost an entire battalion in less than 10 minutes. There was no warning, no adjustment. Shells detonated above our men like they were guided." He stared at the floor. "At first I thought the survivors were broken, shell shock, fear. But the pattern was too precise." "They weren't imagining it," Weiss said. "The fuse removes chance from the equation." Vogt looked up sharply. "I've fought for 2 decades, he said, "from Poland to Russia, Desert and mountain, I've seen weapons come and go, but this nullifies defense itself. He leaned forward. How do you train men when cover no longer protects them? How do you maneuver when every position is exposed from above? Weiss had no reply, because none existed. The proximity fuse did not merely improve artillery. In the end, the contrast was simple. Germany had pursued refinement. America had pursued repetition. German engineers chased perfection, machines that pushed boundaries, designs that dazzled on paper. American engineers asked a different question. Can we build this again tomorrow? And the day after that? And 1,000,000 times more? In a conflict defined by factories rather than duels, the second question proved decisive. The proximity fuse was merely a visible symptom. Behind it stood an entire ecosystem. Standardized training, interchangeable parts, redundant supply lines, and production methods designed to survive disruption rather than collapse under it. American industry did not depend on brilliance at the top. It functioned through systems that assumed human error and corrected for it. Germany's system assumed excellence. America's assumed volume. After the war, when secrecy dissolved and records became public, Carl Weiss discovered that even his bleak estimates had fallen short. The final tally of VT proximity fuses exceeded 22 million units. Not prototypes, not experimental batches. Fully functional electronic devices, each containing sensors, amplifiers, power systems, and detonators, manufactured in less than 2 years of peak output. By comparison, German fuse production during the entire war numbered in the hundreds of millions, but almost all were mechanical, crude by electronic standards, reliant on springs and clockwork rather than circuitry. The Americans had not replaced simple fuses. They had added intelligence to them at scale. The cost of the program surpassed $1 billion wartime dollars, comparable to America's most famous scientific endeavor. But unlike exotic weapons whose impact was symbolic or limited, the proximity fuse reshaped daily combat. It multiplied lethality without increasing risk. 1 shell became 3, sometimes 5. Firepower compounded. Artillery units no longer needed perfect data or ideal conditions. Weather ceased to matter. Terrain ceased to matter. Defensive doctrine ceased to matter. The battlefield became predictable in favor of the side that could fire more rounds. Years later, Weiss would read translated statements from Allied commanders. One American general credited the fuse with turning the tide during critical winter fighting. Another ranked it among the most decisive innovations of the war, not because it was dramatic, but because it was everywhere. British analysts reached similar conclusions. Their studies showed exponential increases in effectiveness, multipliers that no tactical adjustment could counter. The war had not ended because Germany lacked genius. It ended because genius without throughput was irrelevant. Weiss survived the collapse and the occupation. In the summer of 1946, he was questioned by American technical officers reviewing captured German research. They were curious about a report written in the war's final months. Dismissed, ignored, stamped, and forgotten. "You concluded the war was already lost," one officer said, flipping through translated pages. "From captured ammunition alone?" "From what it implied," Weiss answered. "You were looking at one component." "One component," Weiss replied. "That was more advanced than our most complex mass-produced devices, and produced in quantities exceeding our entire comparable output." The officer frowned. You really believe that was enough to draw a strategic conclusion? Weiss nodded. When you encounter a single link in your enemy's supply chain, he said, and that link reveals greater precision, greater resilience, and greater volume than your entire system can support, then the rest becomes inevitable. The officer made a note. We found your assessment marked defeatist. No action taken. Weiss allowed himself a thin smile. The episode surrounding Carl Weiss and the VT proximity fuse was not an anomaly. It was a pattern. Again and again throughout the final years of the war, capable German professionals reached sober, evidence-based conclusions and were dismissed precisely because they were correct. Warnings came from every corner of the system. Naval intelligence officers spoke of American shipyards and were ignored. Armament specialists understood that Germany could not compete in raw output and chose silence to survive. Fighter aces recognized the shifting balance in the air and were accused of undermining morale. Frontline commanders reported logistical impossibilities and were told to show more faith. Weiss's crime was the same as theirs. He trusted data more than doctrine. By examining captured technology, he arrived at a conclusion that ideology could not tolerate. The war had become structurally unwinnable, not difficult, not unfavorable, unwinnable. The regime did not fail because it lacked information. It failed because it rejected information that contradicted belief. The mythology of inherent superiority, racial, technical, historical, was not flexible enough to accommodate evidence. When facts challenged the myth, the facts were discarded. The proximity fuse became a perfect example of this blindness. Despite battlefield reports describing entire units destroyed in seconds, despite consistent patterns of airbursts that no traditional defense could counter, High Command insisted the weapon was either exaggerated or temporary. Some officers claimed German troops would adapt. Others dismissed it as psychological distortion. None accepted the most dangerous possibility, that warfare itself had changed faster than doctrine could follow. But the men in the trenches understood immediately. By 1945, every German infantryman knew the sound of American shells that detonated overhead. Foxholes, once a lifeline, became traps. Depth no longer mattered. Cover no longer mattered. Survival depended less on skill than on luck. Weiss had predicted exactly this outcome. In his report, he wrote that the new fuse removed the primary mechanism by which infantry survived artillery fire. That sentence alone should have triggered alarm at the highest level. Instead, it was stamped, filed, and forgotten. What troubled Weiss most after the war was not that his warning went unheeded, but that the conclusion had been unavoidable long before he wrote it. The numbers were everywhere. American aircraft output dwarfed Germany's. Ship construction surpassed the combined efforts of multiple nations. Ammunition flowed in quantities so vast that allies were supplied, while American forces fought across 2 oceans. This was not efficiency, it was abundance. The United States did not merely outproduce Germany, it redefined what production meant under wartime conditions. Germany's technological achievements were real: jets, rockets, advanced submarines. But they existed in isolation. Singular breakthroughs without the industrial depth to sustain them. America, by contrast, produced systems, networks, pipelines of steel, fuel, electronics, and trained personnel that fed one another continuously. Where Germany built marvels, America built processes. The VT proximity fuse embodied this difference. It was not revolutionary because it was clever. It was revolutionary because it was everywhere. Millions of them. So many that waste became irrelevant. So many that no single tactical response could matter. Each fuse multiplied firepower. Each multiplied loss. Each accelerated the arithmetic of defeat. Weiss had seen all of this reflected in 3 captured shells. 3 small objects that revealed an entire civilization's capacity for organized production. He understood then what many only accepted later. The war's outcome had been determined long before the final battles were fought.